Hello. Uh, my name is Lily Johnson. Wait. I am a Rust engineer and researcher at Astria, and I spend most of my time focused on how we can build the best infrastructure for applications. And today I would like to talk to you all about how we can make application-specific sequencing composable, specifically on the EVM. Um, I really care about this topic because I think the EVM is becoming an uncompetitive place for applications to live. We have seen like a lot of applications start to migrate either to their own chain or to like rollups recently. I feel like that is like not great for the EVM community in general. And I think that application-specific sequencing, which I abbreviate as A2S, as opposed to like other options, is a form of application design which helps applications retain more revenue. And the problem is that the EVM today does not really allow for A2S design in like a composable manner. And this is like very sad because like the EVM is like one of the most highly composable environments that like an application can live on. So if we're losing this composability, like in some senses, like should applications then migrate to like their own chain? This is, I think, like an important question. And the point of this presentation is that I think that this is fixable. I think that we can upgrade and change the EVM in order to make application-specific sequencing in a composable manner viable. So the goal of this talk is to just like diagnose what exactly EVM applications need in order to perform application-specific sequencing, and then lay out potential solutions. So I guess the broad like overview of the talk is first I'm going to go over A2S just so we understand what we're talking about. And then I'm going to like dive into specific sequencing rules for applications just so we can see what the actual problem is. And then the last part of the talk would be laying out potential composability solutions. Yeah, so why do we care about sequencing? So applications have state that represent value ownership, and the order that transactions are ran over the state kind of influences how the value flows through the application. So applications could retain more revenue if they're actually able to control or have more say over how their application state is sequenced. For example, applications are seen to be like leaking value on the layer one today. Because if you think about it, like what are block producers doing? All they do is like sequence and order transactions, and they're actually able to like extract a large amount of revenue from this activity. So the idea and like why like a lot of like application specific sequencing researchers are like excited about this programming pattern is because it enables applications to redirect a lot of this like value back to the applications instead of like letting it flow to the block producers and the validators. So what is application-specific sequencing like in actuality? So it's the idea that applications add additional state transition requirements to how they are sequenced or like how their logic is ran on chain. I think there's like three main types of sequencing restrictions or sequencing rules that applications are interested in. The first one is like an entity restriction rule. The idea behind this rule is that a function call is only valid if and only if a certain entity performs the call. And this is like super useful if an application wants to run like an auction off-chain for its own like MEV opportunity. This would be like instead of like letting like the block producer like collect the value from like a sex-sex arbitrage, the application on-chain DEX would like be able to collect this value itself. The next type of sequencing rule I think that is kind of important is like a ordering restriction sequencing rule. This is super useful for like applications who want to like maximize the welfare for one of their users. Imagine if you have like a lending protocol and they would like to allow their like borrowers to like do liquidity adds before like liquidations occur. So like an ordering restriction rule would just like allow an application to express this in their sequencing. The last type of rule that I think is like kind of important is like a cross app rule. Like when people today criticize that like application-specific sequencing is not composable, this is like what they're mainly referring to. If one application is trying to like impose restrictions on how it is sequenced, like today on the EVM, this is very difficult because you can like accidentally then have conflicts with other applications who are trying to also use your liquidity. So like, yeah, the point of this talk is that today the EVM does not really allow for these to be expressed in a composable manner. A lot of current protocols who are trying to do application-specific sequencing on the EVM, what they are doing is like taking a ton of like user operations or like solver operations and creating like a giant transaction out of them. This is kind of like they're calling it like the fat transaction model. This talk is more about like individual transactions instead of just like one giant transaction, because like I don't really know how to make user op bundling like composable in any way. So also the implication of doing transactions is that these transactions can flow through the normal like builder mempool scenario instead of through like application specific mempools. So this talk is more focused on transactions for A2S. I hope that was like a nice overview of application specific sequencing, and now we're just going to get like a little bit farther into the exact rules so we can understand why like the EVM is like not a great environment for this today. So I'm going to show this slide 3 times for the different sequencing rule types, but I just want you all to notice that like we have a block, which is essentially just like a list of transactions, and then we have like an application, which is going to have some rules, and then we're going to have like the motivation for the rule. So the first rule type I want to go over is the entity restriction sequencing rule. So imagine that we have an on-chain DEX that would like to auction off the first swap. The type of sequencing rule that it would write is that like, hey, I would like the first transaction to be from signer C. And just imagine that this entity C is running an off-chain auction. Like an unaware block builder, when they're constructing the block, they could accidentally sequence other signers' transactions before signer C and cause like unnecessary reverts. And like we really don't want this because one, it's like really bad user experience, but then it's also just like bad in general for like a blockchain like efficiency or like block space efficiency. Because these failed transactions, they don't have to fail, but them still being on chain could like increase the gas price for like everyone else. So it has like external like negative like externalities that like would be better if they didn't exist. And this problem is like similar for like the other rules as well. So like the ordering restriction sequencing rule, again, like let's go back to the user like welfare maximization where we want liquidity adds before liquidations. The way that an application would express this rule would be like saying like I want all of function A to run before function B. And again, like if we have like an unaware block builder, like they're not really going to know like how to sequence these specific sequencing rules per application. So we're gonna have like again unnecessary reverts. And the same issue is still present for like cross-app sequencing rules. So now imagine that we have 2 applications who are trying to compose their sequencing rules. Like let's say that like app 2, which is like a lending protocol, wants to utilize the liquidity in application number 1. So like the app 2, like their rules, like I just want to go after this specific event in application 1. And still, like there's not a great way to know for the block builder to understand like how these rules compose together to like have like to avoid these like unnecessary reverts. So I want to like point out that I think most sequencing rules are really just like relative like ordering requirements. Like the applications aren't saying I need my like transactions to like land in a certain position in the block. I just care about the relative ordering of other transactions inside of the block. Like, and in some ways, like if you have like a static set of applications that all have their own custom sequencing rules like on chain, you can like construct these like different like dependency graphs that like in theory like a builder could be aware of when they're constructing blocks. So I just want y'all to like keep this like idea that there is a way to construct valid blocks with sequencing rules for multiple applications. But the question is like, how do we do that? Because like, again, this is like a bad user experience. So now I want to like shift gears and talk about potential solutions. Like we understand that the problem is that there's no way for like transaction signers and applications to like relatively order their sequencing rules, and I think that that's like the main problem and like the main blocker for application specific sequencing on chain today. So like the first idea is like, what if we just rely on the builder to actually understand like how to like build valid blocks out of all the sequencing rules that could exist? I think that like this is a good idea because like in theory like no changes would have to be added to the VM and it could like actually work today. But I think that this is like kind of a bad idea because like what if more like applications go on chain? Like what does the registration process look like with the builder? Like I think that this is like too dependent on the builder to like respect and like understand the application logic itself, and I feel like it doesn't scale. And like also like what if the builder's like unsophisticated? I think like this could like hurt the EVM design space overall if we rely on this as the main way for ATOS composability. But the cool thing about like crypto is that like we work in like programmable money basically. So I think like a potential solution is making the blocks transaction list like actually more programmable. Like it would be cool if we had a way for like transaction signers and applications to say like, I don't really want this transaction here. Like I want it like relatively placed here where I know like it would actually pass. So like I think we can make blocks more programmable or the block space more programmable. This idea is not new. Dan Robinson and Dave White came out with a paper called Priority is All You Need. And their idea is that like if you just like order blocks and the transactions like inside of the blocks by like a priority signal, then you can like have cool benefits as in like you can use this like guaranteed ordering to like extract MEV payments as an application. And like the idea here is that we can also reuse this signal for application specific like composability. So when an application is now like writing their sequencing rules, they would say like, oh, like for this specific sequencing rule, it would only happen in this like priority range. And what that would enable is then like other transactions to know like what priority to set so that they will not have like unnecessary reverts. And like this is a good idea because like there's no reliance on the builder. Like transactions and applications can like program themselves. But I personally don't really like this idea because the priority signal fee is already used for like other things in the block. First, it's used for like inclusion into a block, like during times of congestion. And then if we're also using it for like MEV tax payments, that's like 2 signals for like one, I guess like signal or one number value. So if we also start using it for like application specific sequencing like composability, that's like 3 different things for like one number. I think that's like not the best like design. So what if we just add like an additional signal in addition to priority? If we add like an additional signal into the block transaction metadata, so basically like now transactions would have a new field that they would specify. Like if we like split up the block space into like different sections that transactions were able to say, now applications would be able to write different sequencing rules to have their transactions like ordered relative to one another correctly. Like I think that this is a good idea because like it's a dedicated signal, so you're not going to have issues if like your A2S rule then conflicts with your MEV tax payment rule. I think it's a cleaner design. And again, you have like no reliance on the builder. The cons, how many sections to have? I think this is like an underexplored design space. I think like maybe 5 sections would work, but that's just because like I think you can build really nice systems out of like restricted conditions. I don't think we need too many sections. I'm not sure if we need both priority ordering and the section ordering. I think we should like decide as a community what is actually needed. And then finally, like this does make generic like block building algorithms more complex because if you're like getting more transactions that like say like need to go into section 0, but like let's say that like a transaction like lower in the list wants to pay more for gas, like how do you as like a neutral block builder like actually construct blocks at that point? Cool, so I think those are just like a couple examples of solutions that we can implement to like enable application specific sequencing on the EVM. I guess like for takeaways, I do think application specific sequencing is very important for EVM app competitiveness. Again, the EVM does not support this today, but I do think that we can like enable this just by making the blocks like a transaction list more programmable. And if you're like an L2 or a rollup and you're interested in exploring this stuff, I know that I would love to talk to you. And also like we at Astria, we like really allow rollups and L2s to like innovate in sequencing rules in general. So yeah, like come talk. But I guess like one last final note is like this research really only like looks at block ordering. It does not deal with like block inclusion. So like a really important thing for application specific sequencing is also just like how do we stop block producers from like censoring transactions? So this is when like a lot of good research that's going around with like TEs for like L2 or multiple concurrent proposers. I think that like this research goes hand in hand with inclusion research because this presentation was like mostly about like ordering. Awesome, cool. Thank you.
Awesome. Thank you. We have any questions for Lily? App specific sequencing? Anyone? Yep.
Thank you for the great talk. I'd like to ask that do we analyze the entire graph of the applications calling one another? And if we do, how do we resolve the situation where, for example, it seems like it's pretty simple to have a situation where the graph is not resolvable, where we have some contradictory rules?
Yeah, I think it's totally possible for people to write sequencing rules that make no sense. So I feel like it's kind of like up to the applications to write rules that compose well with other applications. Like I think there should be like some standards on like, hey, maybe all like Dex applications write their sequencing rules this way, and like just like some like I guess like ERC level like coordination to like enable this.
I mean, each individual rule maybe makes sense, but when you combine them, you can't, and you have to like throw away one of two transactions that can be executed together. What is the solution in this case?
I'm sorry, can you repeat that or expand on that?
For example, we have a rule that A should be executed before D, and then like B before C, and then we have like AC and BD, like in two transactions.
I don't completely follow, but I think that whatever transaction like pays more gas-wise would probably be prioritized.
So for example, if you have liquidation liquidations after adding liquidity, and we have another rule that we have adding liquidity after some other action, right? And then we can have an application that has rule that this action should be executed first, but it also executes liquidation that by another rule should be executed after adding liquidity, but we can add having adding liquidity functionality because we will already have another rule that we should be calling this thing first, and it's just because we have two transactions, so each rule makes sense, but you can't combine them together in one block.
Maybe we could talk offline because
Okay,
that's
sure.
just, yeah. Sorry, that's just like a lot of context.
Hey, Lily. Can you expand a little bit more? I really like this idea of having, signals be for specific reasons, but it's not fully clear to me how we can still build like the most profitable block with this sort of section situation here. Like, is there going to be a separate tip for different sections for you to get included in there? And because I'm seeing, obviously, just in this example, like we have section 1 priority fee 1, but section 2 priority fee 40. Like, there seems to be a difficulty in actually composing like more like blocks that are as profitable as just with the priority. So yeah, I kind of want you to expand on that.
Yeah, so I think this makes block building, as I said, like more difficult. So I know that like some like builder solutions like Flashbots, they're trying to like figure out like, can we run multiple like algorithms at the same time for the same block contents, just to see like which like actually leads to the most like profitable block. Like I don't think there's gonna be like a single algorithm that would like always build the most profitable block. So like multiple concurrent like block building algorithms would like help with this scenario.
Wait, why doesn't having just a simple priority ordering always build the most profitable block?
So in your scenario, is the most profitable block for the block builder?
Yeah, exactly, for the builder.
Yeah, I guess like the priority is just like how much gas you're willing to pay. I think it like, gets more complicated when like you step into like, okay, this transaction like how much gas did that transaction like take up in total? Or actually, I think I need to think more on that, but
Yeah, so maybe like an idea here is like if there's a transaction that pays more but it takes up a lot of gas space, then maybe it's actually beneficial to include 5 with a lower priority fee that take up, maybe less space in the block.
I guess I misspoke, and I think we do want the most highest paying gas transactions in always, But like I guess like when you're constructing this block, like you would include the transaction in section 2 with priority 40 before you like include anything else in your block building set.
A quick follow-up question. So in that graph that you showed, the simple thing is like the application bundler could always call first, and you have everyone else that's on chain calling. How complicated do you think this graph needs to be, right? Like basically, you can think of this as the more complicated this graph, the more complicated the block building will be. Can we actually have a pretty simple, maybe like a 3-4 level graph, and just say that you have to kind of be, your flow has to be within this graph, and then we support it. If not, you're out of luck.
Yeah, so I think like you would only like need to construct this graph if you don't have a way for the transactions to like program themselves, like their like area in the block. Like you only need this graph if the block builder is like trying to like construct the composable sequencing rules. But I do think if we like limit the sections, it would like limit the graph depth to like the number of sections that would be like having to be like sequenced over.
It kind of enforces a line graph, right? The sections basically enforce section 0, 1, 2, 3, 4.
Sorry.
There's graphs within the line graph, though, right?
So, do you envision a new transaction type for this, or are those transaction types just something that are internally parsed within Astria?
So I think like the best outcome would just be like new transaction types on the level of the EVM. But like a starting point is like have this as like a transaction type that like you can like implement on Astria, because like we have like a layer where you can like express like transaction ordering preferences before it hits the layer of the EVM.
So it's basically like an Astria bundle, and within the bundle, like all the transactions are being parsed with sections and priority fees that you guys support, and then hopefully can make it to the enshrine L1 layer.
Yeah, so like Astria like is more sequenced on the block level, but we do have like bundles also.
Okay, thank you.